All right, thanks for joining me, everybody. So this presentation is about the AP CS Principles performance task called the Create task. So the Create task is the coded and submitted project that students need to submit to their what's called the AP Digital Portfolio in order to complete the CS Principles course. And so it is a summative programming project. The students work either independently or with partners. In fact, they actually encourage partnership work. Most of my students actually end up working on their own, but they do actually encourage partnership work as part of the project. So it is worth 30% of the mark. So the other 70% of the CS Principles mark comes from the multiple choice exam that they do. So this task itself is worth 30%. So the requirements for user teachers, a few of them, I'm not going to go into all the details, but this must be it's a summative task. So they can have very little help from you at all. You must provide 12 hours of class time. Now 12 hours of class time might seem like a lot, but that's 12 hours that includes both the coding and all the additional tasks they have to do at the end, which I'll talk about here in just a second. So there's actually this does not need to be a huge, daunting, massive project. It can be if you have the time in your course to give them lots of time to complete this. Sometimes I do in some of the structures of my courses, but other times it's a much smaller project. So just so you know that the details of this, and there's there were handouts and things like that are a part of the course description. So I just have that pre-opened up here. So here's page 169. So it talks about plagiarism policy. It talks about how to prepare your students for the task. There's a bunch of information here, so I'd certainly encourage you to read it before you ever actually fully administer this. And then, so that's kind of the details on their summaries there. So I'm gonna cover a lot of that anyway, so I won't really worry about that too much. But again, creativity and collaboration on this project is encouraged. They don't actually want all your students to be given a single project scope that you want them all to do their version of the same thing. They want it to be something that's unique and creative for students. So here's what your students have to create. They have to create a program, obviously, and we'll talk about what the scope of that program is in just a minute. But they must submit 3 things. So first of all, they don't actually ever submit the actual working code ever. So it doesn't matter what tool, what language they use. The exam writers on the other end don't. The readers, the markers on the other end don't have to set up all the software the way that your students have. All they end up doing is submitting a PDF of all the code, and you'll see in a few minutes they're asked to also highlight a few things in that program code, and a video of it running. So the video shows it working, the code shows them the code they've written. And then what they end up doing is they end up writing, and these end up being worth, in fact, even more than the code itself, some responses to demonstrate that they understand the code that they wrote. And this becomes even more important if they're working with partners, right? They need to demonstrate the understanding just in case the code that they choose to talk about, they can actually choose to talk about code that they specifically didn't write if they're working in a partnership. But they have to obviously really fully understand it. So students can work collaborate on the program code, but they must make the video and complete the written response individually. And this is taken very seriously. Okay, and they have to sign off that as theirs. There's something called the AP Digital Portfolio, which is where the students upload their PDF and video. They answer the written response questions directly into the digital portfolio themselves. So basically, it's a website. They upload. There are some requirements on the size of the files, but they upload a PDF like you'd expect to upload. They upload a video like you'd expect to upload, and then there's a website page where they directly answer some questions, which we'll talk about here in just a couple minutes. Where was I? Okay. So let's talk about the program. So note the 12 hours of class time includes the written responses. So this is done, obviously towards the end of your course usually. But because it's only 12 hours, it does not need to be a big, massive, daunting task. I think I said that well. So here's what has to happen. So the first part is pretty generic, but it's in there, and sometimes you just need a little bit of explanation what it says. So this is coming pasted right out of the course and exam description. Your program must include student-developed program code that contains the following: instructions from input from one of the following: the user, a device, an online data stream, or a file. All this is saying is that one of these only has to happen. There has to be a way for your program to take input. So most programs that students are going to write are going to be some interaction from the user, whether they're typing back and forth into the program, whether they're shooting, clicking the game with a keyboard or a mouse or a joystick or whatever. All of that is legit, right? But technically, they could just have something that loads data from another source, like a file or a device, et cetera, and runs that code. That would also be legit. So this would be something like your students are doing some sort of like a tool that they've written something that's going to process data for them and doesn't need a lot of user interaction. Take this data in from an outside source, process it, and print out the result. So it doesn't have to be all those. Does not have to be all those. It has to be one of these. Okay, so it has to contain that. That's almost for sure. You must use, here's the thing, now we're talking about the actual scope of the code. You must use of at least one list, like an array or an array list or something like that, to represent a collection of data that's stored and used to manage program complexity and help fulfill the program's purpose. Important, the data abstraction must make the program easier to develop. Alternatives would be more complex or easier to maintain, etc. So basically, instead of having 10 or 50 different individual variables, you're going to use a list to store that has 10 slots in that list or something like that. So that's, just to kind of, you have to get your kids to that point. They can do this because that's in the curriculum. Then you must have them write a function or a procedure or a Java method or a subroutine, whatever way you want to call them, whatever you're calling them in your language. They must have at least one procedure that contributes to the program's intended purpose. So it can't just be written superfluously. It has to have a reason. Where there is the student has defined the name. If there is a return type, so if you don't know what that means yet, that's the idea that a function does some work and then sends some information back to where it was called from. And this is, so that's if necessary, but this is required, one or more parameters. So it also has to send data into the method. Okay, so I'm not going to talk about that, what that means exactly right now. That's for another lesson, but you have to make sure that your students are creating their own method or methods that takes in parameters. So they're going to be able to talk about that in their written responses. And so this just says implementation of built-in or existing procedures or language structures such as event handlers or main methods are not considered student developed. So they have to have created this method entirely on their own. They can't just use an existing method even if they're writing internal contents. So in our language is p5.js, for example, we have a draw function. They can't use the draw function. If they create a function down below, like a scene function or a collision function or a shoot function that fulfills these top priorities, look good. It must contain an algorithm that includes, now this is interesting, sequencing, which is just a series of program code, so that's automatic. Selection and iteration, that is in the body of the selected procedure. So selection means it must have some sort of Boolean true-false statement in there, and iteration, so it has to have a loop. So not only do they have to write a function, they have to write a function with a loop. Usually because my students are all, and they also have to have a list, right, from the previous slide. So quite often I'll tell students to write a function or pick a function that they process something in their list, because then they have to have iterated through that list. Obviously you have to call your function somewhere in the code, and instructions for output, and so they must have some sort of output based on the function. So even if it's just print output to the screen. Okay. Or it can be returned to the main to where it's called and do the output there. But there has to be something for that. And so that's important. So the method, the function they have to write, it has some quite specific details. So once they've wrote all the code, so that's basically the entire scope. Write a program that uses a list and has functions that you've written. Otherwise, it's wide open, complete creativity. Okay, so I give students a lot of ideas and things like that. I give them, I tell them to make sure it's small. Don't be too crazy with your scope because you don't have a lot of hours, and I help coach them through it, but I don't help them with the code itself because they have to do it. The video, I'm not going to go over all the details of the video. They are here, and this is again right out of the CED, but the video basically shows it running. The users, they're not supposed to identify themselves in the video. They have to show at least one aspect of the functionality of the program, so it doesn't have to show the whole program even. But their video cannot contain any distinguishing information, and they're not allowed to use voice narration, but they do encourage text captions because they don't want the voice to affect the marking, right? So whether there's accents or male, female, they just want to make sure there's no even illusion or chance of bias over that. And then there's a couple other technical details there, what it has to be, which is actually kind of hard to meet sometimes, the 1 megabyte or the 1 minute and 30 megabytes. So, but just remember, it just only has to do one functionality of the program, show that it runs. The written response is actually where most of the marks come from. And I'll show you the written response where you can learn about the marking here in a couple minutes. So there's several questions. So question A says, describe the overall purpose of the program, describe what functionality the program is demonstrating in the video, and describe the input and output of the program demonstrated in the video. So basically, question A is just talk about the video. Now remember, these have to be done individually, even though they could have wrote the code by themselves with a partner, sorry, but the video and the written responses must be done individually, okay? The students cannot collaborate this at all. So they have to describe the purpose and what the overall functionality showed in the video is. So they've written their own video, so they should be able to do that. Question B asks them to, it's kind of like a two, you see there's 5 parts, but it's actually kind of a 2 kind of part. The first part says, capture and paste 2 program code segments that you developed that contain your list. And so what it does, it says the first program code must show how the data is stored in the list. So basically how they set the list up and what they put into it. That's segment 1. And segment 2 is show the data in the same list being used. Either being processed or something like that. So they have to actually either screenshot or copy and paste those actual two code segments. And then they answer questions about what they chose to show. So provide a written response that does all 3 of the following. Identify the name of the list being used in the response up here. Describe what data contained in the list represents in your program, so what's it all about, and explains how the selected list manages program complexity in your program by explaining why your program cannot be written or how it would be written differently if you do not use the list. So what couldn't you do with this if you didn't have the list? Maybe you couldn't even do all the data processing you want, or how big and complex would this be if you had to use individual variables and all the individual list statements to handle those variables on their own. So that's basically what this is. 200 words, hard cap. Okay, not including the code segments. Question C. It's kind of similar, but now we're going to talk about the function. Capture and paste 2 program segments you developed during the administration of this task that contain a student-developed procedure or function that implements an algorithm used in your program and call to that procedure. So if they've done the selection and the sequencing and the list, that is the algorithm they're talking about. So the first program code must be the student-developed procedure that defines the name, contains the parameters, contains and uses one or more parameters that have an effect, and implements an algorithm that includes sequencing and selection and iteration. We talked about that earlier. And 2, the second program code will show where your student-developed procedure is called. So this is the program itself. This is where the function is actually called. Then provide a written response that does both of the following. Describe in general what the identified procedure does and how it contributes to the overall functionality of the program. And that's kind of a key thing the kids sometimes miss. So what does it do? Yes, but also how does it contribute? And 2, explain in detailed steps how the algorithm implemented in the identified procedure works. Your explanation must be detailed enough for someone else to recreate it. So basically you're going to kind of, if you use the word pseudocode with them, you can talk about it kind of in English. Anyway, what does this do step by step by step? So you describe the functionality and how it works. Question D, provide a written response that does all 3 of the following. Describes 2 calls of the procedure, identify the written response. Each call must pass a different argument that causes a different segment code in the algorithm to execute. So what this is basically saying is describe how this function would be used in 2 different ways. So if you're going to search for something, maybe it's a search function. So if I search for this, explain how it's going to look for the search term, and if I give it this result, if I put in this search term, give me this result. Or if I pass in this parameter, what is the other result? What's the different result because of this parameter? So basically you're going to explain to them 2 different results of your function based on 2 different things you pass into it. Okay, so and that could be like if it's a collision function, maybe it's going to be you're going to pass in and the collision function returns true or false whether or not the 2 things are colliding in a game. So maybe it's here I'm going to pass in data where they are overlapping each other, the result is blank. Here I'm going to pass in data where they're not overlapping, the result is blank. Okay, and so that's what this is all about. So describe 2 different calls in which there are 2 different functions that would have 2 different results. Okay. So this actually is an incorrect slide. The scoring guidelines I actually thought were not in the public domain, but they are now. So I'm going to show you that in just a minute. I'll show you where you can find those. But I'll come back in a second. And I'll show that to end the program, the video. So when to complete the create task. In 1-year programs, if you're doing it all together, I recommend that you complete it with a couple months to spare, if it's a full year course, for example. Again, remember you must allow 12 hours time. Remember it must be submitted in mid-April, and you usually want to give students lots of chance afterwards to kind of work on it. If you're doing a 2 or 3 year program like we have, because we have 1 year program and a 2 or 3 year program in our package, then I recommend you actually do like a practice major project at the end of year 1, and then this becomes something you do in year 2. What else do I have? Some other uses of resources. So if you have access to AP Exam Central, actually I think this is the page I want to show you here in a minute anyway. That's new. Oh, hold on a second, I pause the video and go in there. All right, sorry, I just logged out of my own account so I can show you what it looks like from, in case you don't have an AP account yet. So this is called AP Central. So I go to the exam pages. From there, I go and find Computer Science Principles, which is under Math and Computer Science. There it is there. And this is the page that has all of the information about it. The actual information about the create task and the multiple choice exam itself is under a page called the exam. And you get more resources available if you have an account, but there is actually lots on here. And so if we scroll all the way down on this page, and there's information, there's some videos here there's like an hour-long video that introduces you to this stuff that will even give you more information than I did, but also cover a lot of the same things. Some information about the digital portfolio, which is where they submit. But here's the moment things I wanted to point out to you, is if you go all the way down, so here is the create task samples. Now some of these samples are pretty simplistic depending where you are in your code, but you can see that there is, 8, maybe 9 different responses that shows the video and student written responses. And then what this does is it says this scoring guideline is how it gets marked. And so what ends up happening is there is only 7, I believe it is, marks available. Maybe it's only 6 now. 6 marks available. And so students get those or don't. Yeah, it's only worth 6 points. And so this will tell you sort of how to do those marks. I'm not going to go over that in detail with you now, but you're welcome to have a look at that, or we may cover it a little bit more in our PD. So that's there. But then what's more useful for you is this scoring commentary. This basically says, okay, here, let's look at sample A. What did sample A get on each of those 6 marks? So they got 1, 2, missed 3, 4, 5, 6, got 5 out of 6, whatever. And so for each one of these samples, it shows you here. So I'll just show you what I mean. So there's the samples. Here's the mark they received. So you can see the first ones get better marks than the last ones. And then below it explains why or they got the mark or why they didn't. So it's a really, really useful thing for you as a teacher to go through, and also really, really important for you as a student to go through and say, hey, how come this person didn't get this mark? Okay, and so you work your way through that. And so these are basically, these rows somewhat correspond to the written response questions. Okay, and so that's it. That's the create task. I do have some samples available, but most of my samples available are for Java, and they're in the older create task, which is a little bit different. So hopefully, I'm recording this video in the early summer of 2021. I may be able to get you guys some JavaScript ones before the end of the summer, but certainly next year when I have a bunch of my 2021-22 students, most of them are going to write the create task in JavaScript, and so I'll be able to share you more at that point in time, depending on when you watch this video. Hopefully, those will be available then. But again, those tasks are available to teachers to attend our PD sessions, so that they are, relatively secure documents. So thanks everybody. Hope this was helpful, and we'll talk to you next time. Bye-bye.